So I'm going to pick a card, look at it, put it back in, shuffle, pick a card, look at it, put it 5 times. Why is it important that I have to put that card back in? Because it's got to have the same probability every trial. If I kept the card, the probability changes each time and it's not binomial anymore. So is this binomial? Does it meet the 3 things? First thing is, do I know exactly how many trials I'm doing? How many? 5 trials, picking a card 5 times. Is it success? Oh, I don't even know what the question is yet. Oh, so you don't even know that. We're looking at picking, getting a club. So if I'm looking at drawing out a club, is the probability of success the same on each trial? Yeah. So I'm going to write that down. We are going to be looking for pick a club. So that's my event. So I either get a club or I don't. There's my success failure. So what's the probability of success on this? If I'm looking at whether the card is a club or not. 13 out of 52. Or, what does that reduce down to? 1 what? 1/4 the deck. Yeah, that was pretty bad. Yeah, she did. It's a quarter of the deck. Does the calculator care whether you put in 13 out of 52? Nope. 1/4 works. Okay. What values could X take on? X is the number of successes. What's the fewest number of successes I could have on my 5 trials? 0, or 1, 2, 3, 4, or 5. Okay. So I'm going to ask some probability questions now. What's the probability of getting 3 club cards? Not the 3 of clubs, but 3 of the cards I pick out are clubs. 3 club cards. So out of the 5, I want to see what's the probability that I get exactly 3 club cards. So since it's binomial, we're going to go to the binomial. I just used the B and then PDF. Tell me what I have to feed the calculator here. In what order? 5 trials. 1/4. Exactly 3 successes, so a 3 has to go there. Okay, let's find that on the calculator. Oh, it's on. Okay, distribution. DISTR. And then go down to binom. Yeah. No, I want you to pay attention. You should find 2 of them that say binom on them. It's 10 and A. See, I got a binom PDF and I got a binom CDF. Monday you're going to know what the CDF is, so just don't touch that one today. So then after Monday you're going to say, boy, which one is it? Is it a PDF or a CDF? But for now, PDF. All I got to do is simple. 5, comma, I'm going to go 0.25, but you can put the fraction in, 3. You don't have to do any work anymore. You just got to know what program to grab. Yeah. So the probability there is about 0.08, and I think the book goes out 3 places on these. What's the probability of getting all 5 club cards? What does that change? What does that change? The last number. 5 trials, still 1/4 success, 5 successes. I'm just going to do a second entry and then just back into this. Make that a 5.
Wait, how did you do that?
Second enter, yep, and it retypes the line and lets you back into it. Some of the newer operating systems, I think, let you arrow up and change the number. Mine doesn't. But you guys can, on those calculators, get new operating systems. You just have to plug them into your computer and go to Texas Instruments and they update to the newest system. Free, yep. Yeah, these are upgradable, just not quite as easy as your phone is through wireless. But yeah, you can go to Texas Instruments and get the newest operating system for your calculator at any time. Okay. Okay, 9.76. How can a probability be over 1? Oh, you gotta look on the end of the line there. See that e to the -4? What does that mean? Times 10 to the -4th. So not likely. Okay. All right, make a probability distribution for the following situation. So we've got a survey of retired people who are relying on their Social Security to get them through their retirement. In other words, they absolutely need the money from Social Security to survive. And there's a little survey, it's coming right from your book here. It's this one. This says not banking on Social Security. So the people that are, what does it tell us here? Retired and working. So I'm looking at classes of people. 71% of retired people need the Social Security. 36% of working people are saying, I know that's not going to help me out later on, I'm going to say no. So this is what we've got going on here. So we are going to pick 7 people from that survey and ask, are you relying on Social Security for retirement? Are you relying on Social Security for retirement? How can they answer that question? Yes or no. Yes is their success, no is their failure. Okay, we want to make a probability distribution for this problem. What's the probability distribution from yesterday? The whole table that shows all possible outcomes. So let's see. What values can X take on here? Remember, X is the number of successes, or it's the number of people that say, yes, I'm relying. What is it? 0 through 7. Well, I've got 8 probabilities to come up with here. So then the probability distribution is just asking me to find each one of those separately. So what's the probability that of my 7, none of them are relying on Social Security? Blah, blah, blah. Oh, we're actually asking 7 retirees, not 7 people, but 7 retired people. That's kind of important. Retired people. So we need, when we run our probability distribution, I need to know 3 values. They are N, P, and X. Do I know how many trials I'm running? 7. Do I know the probability of a success? Did I give that to you here?
Yes.
Where? I did not give you a number in there. Where are you going to get it from?
Oh, probably.
From a graph. So we were looking, I don't know if you can see it very well, but Social Security is right here. The retired people are the red. It's 71%. So there's my probability that a retired person is relying on Social Security, is this one number here. So they might give you a graph and you've got to decide which percentage are we looking at. And so you had to grab this one, because it was dealing with Social Security and retired people. So 71% is the P. So that'll go in as 0.71. And then X, we've got the 0 through 7. Okay. Seems a little monotonous to have to do that binomial PDF 8 times, right? You could do it, right? You just have to keep changing that last number and writing them down. But those wonderful programmers at Texas Instruments, better write it down. What are you going to tell it for the number of trials? Nope. How many trials are you doing? You got to put the n value first. 7 trials. Probability of a success is 0.71. And at this point, I could put in a 0, get that number. Redo it, put in a 1, get that number. Redo it, put in a 2. But, like I said, the Texas Instruments people know the kinds of problems you're going to be doing. If I don't put in an X at all, it gives me all of them right in order, starting with the 0 one. So 7 trials. So what's the probability of no successes? -4. And you just have to use your arrow to the right to see the rest of them. It'll keep kicking them over. I don't care how many places you go out, just at least give me 2 non-zero numbers. I think I'm going to be good there. Okay, I'm going to quit. Your homework is going to be page 73. And I guess if you don't have a calculator, you can at least give me the line that you would type in. If you don't have one at home, that'll work too. You just won't be able to check your answers. 4-2, problems 4 through 6. 7 through 12, you're only going to do part A. There's like an A, B, C in every single one of these, so only part A. And then 15 and 16. So you even on, you do have to give me the calculator line, so in case you get them wrong, at least you know, if you just write down an answer and it's wrong, you have no clue what you did wrong. So give me the calculator line and your answer. So if you don't have the calculator, at least you've got the calculator line there.